Algebra 1 skills number 39, even and odd functions. An even function is a function where f of x is equal to f of negative x. And for this particular video, since it's an Algebra 1 video, we're not really going to talk about this much. In short, this says if you replace every x with a negative x, it actually stays the same sign. But we're going to mostly take it from perspective 2, and that for polynomials, all variable exponents are even. It'll be important to highlight the word variable exponents. Of course, not every function is a polynomial, so you have to consider other functions, and this number 2 doesn't always help, but that's the main focus of this video. Also, the graph will be symmetrical to the y-axis, so we'll talk about what that means. For an odd function, if you replace every x with a negative x, the entire function is exactly the opposite of the original. But again, we're not going to focus on that so much. We're going to focus on perspective 2. For polynomials, all variable exponents are odd, and this is symmetrical to the origin. So let's take a moment to talk about symmetry. Even though this is not the primary focus of this video, it's still important that you know this. Y-axis symmetry is just like it sounds. This is the y-axis. So if you were to fold along that y-axis, the graph would fold onto itself. The origin is, you can kind of think of it as doing opposite and opposite corners, or if you were to fold twice, both across the y-axis and across the x-axis, then the opposite corners would come onto themselves. Either which way that you want to think about that. But remember, even functions are symmetric to the y-axis, odd functions are symmetric to the origin. But again, we're going to mostly focus on the exponents. So for this one, are the following even or odd? If you have even exponents, we don't care about 6 and 7. We don't care that 7 is odd. Both are variable exponents are even, therefore this is an even function. Question 2, again, we don't really care about that 8 and 2 are both even. That doesn't matter. We care only about the variable exponents. They're both odd, therefore it's odd. It's very important to know this when you're answering these questions, that if you see x or any variable, that's understood to be that variable to the first power. This would be an odd term, okay, because again, the variable exponent that we highlight in red here is odd. If you see just a number, now here I just use 3, you could use any number you want. That is the same thing as 3 times x to the 0 power, okay, so anything to the 0 power except 0 itself is 1. So if I put x to the 0 power beside it, then these are actually equal. So this would be an even term. Even though the number 3 in this example is odd, that doesn't matter. It's all about the variable exponents, not the coefficients. Okay, so it's important to know that. So I want to ask again, is the following even, odd, or neither for this third example? So here, at first you might think that, well, maybe it's neither, but if you look, we have a 5 here. That is the same thing as 5 times x to the 0 power, and both 0 and 2 are even. 0 is an even number, because if you divide by 2, it has no remainder. These are both even, therefore it's an even function. Example 4 is the following even, odd, or neither. Again, here you have x with no visible exponent, but you do see the x. Therefore, that's x to the first power. And what we have is a combination of even and odd. This is odd. The other two, though, are even. Again, only looking at the red, we don't care about the coefficients. Because there's a mixture, then this would be neither. It's neither even nor odd. And one more look here. Let's look at a graph. Same question. The question is not printed here, but you would ask yourself, okay, what kind of symmetry do we have here? This is symmetry to the y-axis. If you fold along the y-axis, it would fold onto itself. Therefore, this function is symmetric, or is even. Okay, odd would be symmetric to the origin. So even and odd functions.